Hello everyone, Mr. Hissner here, and today I want to continue looking at our angle proofs. Now last time we looked at a bisector and how to kind of work with a bisector in an angle proof. Today I'm going to focus on linear pairs and try to really focus in on linear pairs and just the properties that we see in those idea of linear pair proofs. So let's look at, no, not this one. Where is it? This one. Okay, so I'm going to look at this one here, number 2. And what do we have here? Well, we have two pieces of given information. We have piece number 1 here, that angle 2 and angle 3 are the same. And we have that angle 1 and angle 2 form a linear pair. So we have this piece of given information and we have this piece of given information. Now, here is what I'm thinking. Here's what I'm thinking. I can see this already because if the measure of angle 1 plus the measure of angle 2 is equal to 180 and measure of angle 2 and 3 are the same, then I'm probably going to make a substitution here, and then I can say measure of angle 1 plus measure of angle 3 is equal to 180, and thus plus, so thus supplementary. So that's really my discussion here. Linear pairs are supplementary, and then I'm going to probably make a substitution. And because if those two are the same, if 2 and 3 are the same, then 1 plus 3 should also be 180, and thus those two will be supplementary. And in fact, that is what we want to prove. We want to prove that 1 and 3 are supplementary. So that's the idea. Since 1 and 2 are supplementary, since 1 and 2 are supplementary and 2 and 3 are the same, I'm just going to swap these two and I'm going to say, okay, that means that 1 and 3 also have to be supplementary. So now let's look at this proof. Let's see what we have here. So two angles are congruent, then they are equal. So this is the definition of congruence, which is pretty easy. Then we have number 3 is our linear pair that's given to us. And if it's a linear pair, then it's supplementary. If it's a linear pair, then it's supplementary. This is the supplement theorem. That's the supplement theorem. And so, yeah, that's just what I'm going to write, supplement theorem. And if they are supplementary, so from going from 4 to 5, if two angles are supplementary, then their sum is 180. And that is the definition of supplementary. So the theorem says that a linear pair is supplementary. The definition says supplementary is has a sum of 180. And now we get down to really just the potatoes and the meat here, and notice what's changing from steps 5 to 6 is that measure of angle 2 turns into a measure of angle 3, and that was declared in our second step. This is a substitution. And really, now, again, we're going to use that definition of supplementary. Because if two angles, it's a biconditional statement, if two angles add together to be 180, then they are supplementary. If two angles are supplementary, then they have a sum of 180. And so it is a biconditional statement. Both of those, the inverse and the converse, are going to both, not the inverse, the conditional and the converse are going to both be the definition of supplementary. So definition of supplementary. I'm just going to use just sub. So this one wasn't that bad. However, I think most of these proofs you'll find won't be that bad. It's just going to be basically laying out the things that you know, then using some theorem, some substitution, and then basically wrapping it back up.